Good morning class 8. Welcome to today's online class. Today we will discuss about the last part of the chapter 6 combustion and flame. In our previous classes we had discussed about different types of combustion, different types of fire extinguishers and different zones of a candle flame. Today we will discuss on fuel and its different aspects. Fuel. The material which are burned to produce a large amount of heat and other forms of energy are known as fuels. Fuels are classified on the basis of physical state in which they occur. So fuels are classified as follows: solid fuels, liquid fuels and gaseous fuels. Solid fuels. They exist in solid state at room temperature. For example, coal, wood, paraffin wax, etc. Liquid fuels, they exist in liquid state at room temperature. For example, kerosene, petrol, diesel, etc. Gaseous fuels, they exist in gaseous state at room temperature. For example, liquefied petroleum gas or LPG, what we use as cooking gas, compressed natural gas or CNG, that also we see in transport vehicles. Now we have to know the calorific value of fuel. All the fuels produce heat energy on burning, that we all know. Different fuels produce different amount of heat on burning. The amount of heat liberated when a unit mass of a fuel is burned gives us a measure of the energy content of that fuel. Now the energy given by a burning candle will not be same as the energy giving when petroleum fuels are being burned. The burning heat and energy released by a burning candle will be much less than burning petroleum, that we all know. So the calorific value of a fuel is expressed in kilojoule per kilogram. It determines whether a given fuel is a good fuel or bad fuel. The higher the calorific value, the better the fuel. The calorific values of some common fuels are as follows, and they are all expressed in kilojoules per kg. So the table goes like this, you can see. But there are some certain characters of a good fuel. It should be fairly cheap and easily available. It should have high calorific value, because the more the calorific value, the type of fuel, it will be good. We have already known. It should be easy to handle, safe to transport and convenient to store. It should not cause air pollution on burning. It should not leave ash or solid residue after burning. It should have a proper ignition temperature. The ignition temperature, remember we talked about it in our first class in this discussing in this chapter. So the ignition temperature should neither be too low, then the fuel will catch fire too easily, nor too high. The fuel will be difficult to ignite. But no known fuel has all the good characteristics, because all these good characteristics are not known to be found in a single fuel, because solid fuels are easy to store. No doubt they are easy to store, but they have very high ignition. They have very high ignition, that is, they can catch fire difficult to ignite, and they leave solid residue, and they also leave solid residue that should not be done by a good fuel, and produce smoke when burned. For example, wood, if wood is burnt, it produces smoke, and ash and coal. Liquid fuels, they are easier to store than gaseous fuels because they have higher ignition temperature. Gaseous fuels, these are difficult to store. They have to compress at high pressure and they are stored in sealed cylinders or tankers. Gaseous fuels are useful because they do not leave solid byproducts when burned. Now this is a good thing about the gaseous fuels, but bad things is that they are they are difficult to store, and they have to kept very carefully in sealed cylinders or tankers. Natural gas is a closest to an ideal or good fuel, but it is not very easy to handle. Systems have been established for a relatively slow method of transport of compressed natural gas through pipelines. Hydrogen has the highest calorific value, but its ignition temperature is very low. It is not safe to handle. Harmful byproducts formed by the combustion of fuels. Combustion leads to the release of energy that we all know. Chemical reactions that take place lead to the formation of many byproducts. Which can be harmful to health and environment. The burning of fossil fuels like coal, petroleum, etc., various air pollutants like carbon monoxide, carbon dioxide, oxides of sulfur and nitrogen, and unburnt carbon particles which causes air pollution. Product formation of combustion depends upon the supply of oxygen. Combustion leads to the production of smoke, that is, it will create air pollution. Small particles are a part of suspended particulate matter which can enter the lungs and cause respiratory disease. So these are also harmful to our body. Now talking about carbon monoxide, it is produced during the combustion of fuel. As we can see, oxygen is needed for combustion, that we all know. So when methane is burnt, it will produce carbon monoxide, and as byproduct water and energy as heat and light. So carbon monoxide is a byproduct that is being produced but harmful to our body. Talking about carbon dioxide, when a fuel burns with sufficient supply oxygen, it leads to the complete combustion and produces carbon dioxide, water and energy. Again, methane is burnt in oxygen, it will produce sufficient oxygen, then it produces carbon dioxide, water and energy, and we all know carbon dioxide is an air pollutant. Some fuels such as coal and diesel contain sulfur, which changes to sulfur dioxide on combustion, and that is also an pollutant. Automobile engines give out nitrogen. Besides being poisonous, these oxides, sulfur dioxide and nitrogen dioxides, dissolves in rainwater to form acids. This falls on the ground as acid rain. Now this acid rain is also harmful to our body and also to the nature. Some lead compounds are also released in the atmosphere by the exhausts of vehicles. So these lead compounds are also pollutants to the environment. So these are the aspects of combustion and flames chapter. I hope you understood the concept of this chapter. From our next class we will start a new chapter. Till then, happy learning.